All right, thank you for joining us here at the Startup Loft. I'm actually very excited to introduce our next speaker. Steve Salevan formerly worked at Red Hat, Tumblr, Twitter, and now Spine. So Steve is a co-founder or founder at Spine, and please welcome him. Thank you.
Hey y'all, how you doing? Thanks so much for the introduction. So my name's Steve Salevan, and I founded a company called Spine. What we do is that we provide a cloud-native platform within reach of a click. And in the process of building out this platform over the last couple of years, we found that we wrote a heaping help in automation. So before we go any further, I want to ask just a quick question. If I could just see a quick show of hands, how many in this audience are in a startup? Oh, all right. Now, how many in this audience have used the Amazon Web Services? Oh, excellent. Well, I think that you have attended the right talk, because we are going to talk about how to use the Amazon Web Services, how to bend them to your will to create a truly powerful cloud-native platform of your own using the automation that we wrote for Spine. We call it SPINESIBLE. So, first off, I gotta say, this is the first time I used PowerPoint in a while, so I've tried to mix every single transition I could find in PowerPoint into this presentation. So definitely some good ones in here. So let's imagine this purely hypothetical situation. Let's say that you have just created an Amazon Web Services account. You have your Amazon key, you have your secret key, you're ready to build something cool on top of it. But you find that there is a true panoply of incredibly powerful services at your avail. And you're like, well, what do I do with these things? Well, another thing that you're probably thinking about is that, well, you enjoy sleeping, and you just kind of generally enjoy using computers to do manual work. So being of sound mind and spirit, you want to automate your infrastructure operations. That is a perfectly reasonable and a very, very good idea indeed. So finally, you probably are using something called Docker. You might be using Docker, you might be using Mesos. You might want to use Docker and Mesos, but the thing is, these things are a little bit tricky to set up. And in fact, they can be quite tricky to set up. And so you'd like to set this up on top of this AWS infrastructure. And so you're looking down the road, you check out the Mesos or the Kubernetes page, and you're like, well, Jim Jangle, there's just a whole lot of stuff to do here, a lot of commands, a lot of configuration. Wouldn't it be awesome to bring all of this up with a single command? Well, now you can, using SPINESIBLE. So what is SPINESIBLE? Again, it is the Ansible automation at the core of our cloud-native platform, built on top of all of the amazingly powerful services afforded to us by the Amazon Web Services. At Spine, we use Ansible for everything from instance provisioning to the provisioning of all AWS services, including things like VPCs, security groups, S3 buckets, EBS volumes. The list truly goes on and on. And so, again, we've written a whole lot of automation to help us along the way, and we have just open sourced it as of several days ago to help you do much the same. So here's how it works. I hesitate to call this a framework. It's probably more of a collection of useful best practices to help you make the most out of using Ansible. First and foremost is this guy right here. So we rely upon this concept in SPINESIBLE called a data center. What is a data center, you might ask? Well, a data center is a collection of Amazon resources that are based in a region from AWS, like US East 1 or US West 1. The reason why we decide to demarcate these in this thing called a data center is that oftentimes you'll have services that will want to run in one data center or another, different IAM policies and the like. So it's helpful to have that configuration information corralled into a common place with which your automation and any of the provisioning stuff can get at it. Another thing that we incorporate into this are all of the nice AWS integrations with Ansible. The dynamic inventory script is one of the most powerful things that I think you can really incorporate into any Ansible repo that you use. What's cool about this is that the dynamic inventory script in Ansible allows you to take any arbitrary set of tags or other bits of information information about your Amazon infrastructure and then target automation against it, which is truly powerful because let's say that you swap out an EC2 instance, or let's say that you add an EC2 instance or something else like that. By using the dynamic inventory script that allows you to automatically handle that case without having to update a hosts file. Personally, I think host files are a little bit out of the 90s, so I'm not really a big fan of that. So always use a dynamic inventory script, and that comes straight out the box with SPINESIBLE. Another thing that we include are just some custom tooling scripts. So again, using some of the Ansible tools like the Ansible playbook command or the straight Ansible command, it can be a little bit of a verbose experience, especially if you're using some features like the Vault. So we've just added some wrapper scripts to simplify that experience. We've tied it all in with a Python virtual env. So if you just have a laptop and a little bit of ambition, you can get yourself set up in under 5 minutes with this repo. The next step, and I think this is probably like the central kind of part of this entire framework that we've built, is all of our provisioning automation. So, the typical Ansible workflow with AWS is that you're going to go up to the AWS UI, and you're going to manually create EC2 instances, VPCs, and other things like that, and then you're going to create a host file and then target automation against that. Personally, I don't like that very much. The reason why I don't is that it's always helpful to have a single point of truth about any arbitrary resource that you obtain from Amazon. It just makes sense because let's say that it's 3 a.m, you've just gotten a page for some reason, and it might be related to something in your Amazon infrastructure. It is extremely helpful to have one truly useful place to find that information to help you resolve that incident. So that is effectively what stands behind all of our provisioning automation. Our provisioning automation will help you create everything from VPCs and VPC subnets to internal and external Route 53 zones, IAM roles, users, and instance profiles, and finally the EC2 instances atop which you will run any of your cloud-native services. Finally, and this is the other major feature, we have included over 30 different kinds of Ansible roles. So what might you say is an Ansible role? So it's very similar in a lot of ways to the Puppet role or Chef cookbook. So it contains a bunch of common reusable automation that you can use to go and build a useful service, such as Kafka or Mesos, or Master War Agent, or Zookeeper or Elasticsearch. And as you might imagine, those are all built right in, based upon the same battle-tested stuff that we use to build Spine. So check out this transition. It's one of my faves right here. So, again, integrating Ansible with AWS is kind of a multi-step process. You have to use this dynamic inventory script. And again, we've configured it to work with AWS straight out the box. So as soon as you check out that repo, you can run one command and be ready to go. The next step, though, is that once you've checked out that repo, you probably should configure it to work with your own custom use case. So what does that look like? Well, we probably should talk a little bit about our framework to do that. So again, it includes support for multi-DC operations and includes tools and scripting to simplify that, and then obviously provides this configuration basis upon which you can configure this. So this is a general overview of some of the stuff that framework provides. It's, for instance, the wrapper scripts that I referred to earlier, as well as the overarching directory structure. So I'm going to get right back into that. So talking about provisioning, now that we're back to that point, we have to figure out how to specify the constraints to actually provision up our Amazon resources. Again, this is often done manually, and I feel that can really introduce a lot of operator error into the equation, particularly because let's say that you're creating VPCs and VPC subnets. There's a lot of reasoning that you have to do to be certain that these things can talk to one another. So, with our repo here, you specify a set of constraints. You basically say that you want a VPC and you want several subnets within it. You say that you want a Route 53 zone. You specify the actual DNS zones that those will go into, as well as the VPC attachments that those will be attached to. You specify the IAM policies, roles, and instance profiles. And finally, you specify the EC2 instances and the size and base images for all of the EBS volumes. What does that look like? Well, it looks something like this. So right here, you're looking at a VPC specification. We specify the master CIDR block. In this case, it's just 10/16 CIDR block. You specify some tags. I strongly recommend using tags very heavily when working with any kind of AWS automation because it helps you find resources in a jiffy. Finally, you specify the subnets that will exist within it and whether you want an internet gateway. So an internet gateway allows you to connect a VPC within Amazon to the outside internet. And so once you have all those subnets, you also will need to associate a subnet with an Amazon availability zone. We recommend using 4 if you're using the US East 1 data center because there are 4 availability zones in US East 1. Next up, you specify a route table. So route table, you specify all the subnets, and then you specify the ways that that particular VPC can interact with other VPCs. In this case, we strictly specify that it can speak to the internet and nothing else. However, if you have multiple VPCs and you'd like to interrelate them, but still preserve that nice physical separation that VPC provides you, you can add additional routes into here. And in fact, we have some examples for that in our repo. Next up, these are the IAM policies. So I don't know if you can see this too well, but what this does is that it allows you to specify this abstraction for a policy, the JSON of the policy itself, and then finally what you're going to call it, and then effectively the users and roles that will use that policy. If you're using a role, you're also going to have to associate something called a trust policy with it, which is effectively what they call a policy granting policy in IAM parlance. What that means is that it's something that allows the instance using, or the instance or whatever you might want to have using that to actually get at the resources that your IAM profile provides. So in this case, we're just specifying a built-in one, the default EC2 policy, which will allow any EC2 instance running to access the resources that are afforded to it by this particular IAM policy. Finally, you specify the Route 53 zones. In this case, we're associating these zones to the VPC IDs that were given upon the creation of a VPC. And that, again, was powered by our provisioning automation. Finally, the final step in the whole provisioning process is how you actually go about creating the instances upon which your services will run. So obviously, different kinds of instances, say an Elasticsearch instance versus a Mesos master instance, will have radically different usage scenarios. And so as a result of that, you're likely going to want to target them different kinds of instance types, different kinds of quantities, and different kinds of EBS volume types and sizes. So all of this can be specified here. You also specify your security group rules for each one, as well as your default egress policies. Finally, you specify the Route 53 zone that all instances in this zone will be provisioned into, and all of the VPCs that those will live in. So that handles a whole lot of stuff that you would end up doing manually, straight out the box, in a single configuration file that you can refer to easily. Visual inspection is trivial with all this. Woo! That's a good one. So, once you've provisioned those EC2 resources, you're going to want to set up the services that run on top of them. So, obviously this is something that's going to be like a your mileage might vary situation depending upon what kind of a product you're building on top of AWS. But the fundamental component that they all share is this notion of the Amazon Ansible role. So an Ansible role, again, is this reusable chunk of automation and template logic that allows you to stand up a complex piece of infrastructure. What's cool about roles is that you can compose them together to build extremely powerful services. So in this case, we basically create a base playbook that looks something like this. In this case, we're just setting up an Elasticsearch master node. So we're including this role here called Elasticsearch. And then what you do in the vars section is to specify the unique configuration for that class of nodes. In this case, we're specifying some information to the Elasticsearch role that tells it to be a master. We tell it some information about the service discovery mechanism, which uses EC2. That's in fact why we have that default IAM profile, because IAM includes an extremely powerful feature called instance profiles. So how many out here have ever used EC2 credentials or AWS credentials within EC2 to use a service like Dynamo or S3 or something like that? So generally, it's kind of a pain in the butt to set up a distribution mechanism that's secure for that. Thankfully, instance profiles makes this very easy because those will be exposed via something called the instance metadata endpoint, which is just a little endpoint that's sitting on your server that you can go and curl. It returns a JSON document that you can parse, and if you include an IAM instance profile, that will also include a set of Amazon credentials that all of the default Amazon toolkits, be it Bato or the SDK for Java or the Golang SDK, all use straight out of the box, as long as you don't specify your own credentials file. So Elasticsearch's discovery and S3 backup automation uses that out of the box, and we specify some tags that it can use to figure out where all of the other nodes in that Elasticsearch cluster are. Finally, we include these two files here, the DC config, which you just saw, and then something called DC vars, which is a record of all of the provisioned AWS resources. Because every time you provision up an AWS resource, it will provide you with a resource ID, like vpc.blah, blah, 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 or EBS blah, 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 blah. And so all of that stuff is really useful to track. And additionally, it's very useful for targeting automation off of. And so that is contained within this thing called a DC vars file. As you can see up here, we're targeting it against a specific tag. So every time we provision up an EC2 instance within SPINESIBLE, it will attach several tags to it. One of them will be this thing called an Ansible group. So an Ansible group is effectively everything within this file. All the nodes that are Elasticsearch masters will be tagged with Ansible group ES master, and then you can target automation against that. Why this is a powerful concept is quite straightforward. It's powerful because, again, if your master configuration changes, which can happen quite frequently in production, you can trivially rerun this automation to reprovision up the nodes that have failed, and then run this automation to go and reset up the cluster without further human intervention, which I think is a very, very powerful concept indeed. So, going back to this is kind of what it looks like on the master level. So you have something called a section, which is what you just saw earlier, and then you have roles within it, which combine these Ansible roles together. So, for instance, Mesos and Aurora, the master for that will need to run the Aurora scheduler, the Mesos master, and then a Zookeeper node. We also use something called an aggregator node within Spine, which is something that aggregates using Flume and Kafka all of the container logs that come from our instances. Right now, we've configured that to talk directly to Loggly, but it also can forward off to Elasticsearch very trivially. And so we've included that role in SPINESIBLE as well. Finally, we also have some roles in here to support running an Elasticsearch infrastructure as well as raw compute nodes, including Mesos and HA proxy. You may want to set up something like Synapse or another common service discovery mechanism on top of that for doing microservice communications. So that's just about it. I really appreciate y'all sitting through my talk. And if you'd be interested in checking this out, we would absolutely love to have you use this. We wrote a post about this on our blog, blog.spi.ne. We also have this up on GitHub, getspine/SPINESIBLE. If you have any trouble with it, please join our Slack. We would absolutely love to help you get this going. One way or another, we're just really excited to show folks what like a true cloud-native experience can be. And we really want to help you get there because we feel like this is truly the future of computing right now. It's the abstraction upon which all services in the 21st century will be built. I'm pretty sure on the Starship Enterprise, once that's going on, Jean-Luc Picard is going to be talking about whatever microservice is powering the warp drive or what have you. So one way or another, we really want to show folks what the future looks like. And we feel like SPINESIBLE is like the first step that we can take to show you what that is. So please check it out. We really appreciate your time. And if you have any questions, please feel free to ask. Thanks so much. Yes. That's a great question. So out of the box, this is configured to use the Mesos Docker containerizer. So if you go to the Aurora site, aurora.apache.org, because we use the Aurora scheduler, it has built-in support for scheduling Docker images and an example that you can use there that you can write up and use to talk with the cluster that this will build out for you. So as long as you have an image and it's present on the Docker Hub somewhere, just follow through that tutorial and you'll be ready to rock and roll. Any further questions? Mhm. So that's a great question. The question was, what happens after this provisioning step occurs? Does that get transliterated into a JSON call to the AWS API? So the way that this works is through the AWS modules that are included in Ansible. So Ansible has a very rich collection of modules that largely just wrap functionality from the popular Python Bato library, which will indeed make those JSON calls to the API. So one of the things that we found about those modules was that the documentation, particularly around a complex usage scenario, was somewhat lacking. And so that was actually one of the big reasons we wanted to open source this. If nothing else, to show you how to use some of these powerful modules to do some useful things with AWS. Like anything, I feel that any kind of infrastructure automation is best when you've spent some time reading it and you pick and choose what works best for your organization, because everybody's infrastructure is a little bit different. And so as a result of that, I definitely recommend there's a role in there called provision DC, and that's where all of that stuff is situated. And it'll show you basically how we go and provision up VPCs and Route 53 zones and IAM policies and the whole 9 yards. And I think it'll serve as a very useful set of instructions on how to use those particular modules. Yes? That's another great question. So I didn't mention this in my post, but there's a feature in Ansible called the Ansible Vault. And what it is that it applies a symmetric encryption to a block of YAML. It uses a password, which, I don't know, it's fairly secure. But the nice thing about this is that once it has been encrypted, it allows you to go and check that into source control. So we have included a basic vault file with SPINESIBLE. We've created a highly secure password. It's called Please Change This Password, which definitely one of my faves. I strongly, if you have to do credential distribution, which is something we all have to do, I think the Vault's probably your best bet because it's simple and straightforward. Once you get to, say, like the 10 to 20,000 node case, you might consider using something else. HashiCorp Vault, in tandem with an IAM instance profile and KMS, is actually a fairly powerful solution for that case. But by the time you're at a 10 to 20K use case, I'm pretty sure, well, suffice to say, that's going to be a good place to be. So that's, yes. Oh my, you've asked one of my favorite questions. The question was, you want to do service discovery. What would you recommend for that? So when I worked at Twitter, I led up the resilience program out there. We ensured that the site could survive all of their high traffic events, like the World Cup and the New Year's and what have you. And one of the most interesting results that came out of that work was understanding all of the different ways that RPCs can fail between microservices. I think this is one of the most fundamentally painful things about a modern 21st century infrastructure. And so, in response to all of that, Twitter came up with a piece of software called Finagle. And what Finagle does is that it basically encapsulates a lot of complex reverse proxy logic into a single service that runs on every client. So every client is constantly making decisions about where best to send an RPC and when to retry and when to time out, and all of these things that ultimately have been shown via many white papers. Jeff Dean from Google wrote a really good one about this that help you to understand, how to most effectively and with the least latency make a successful RPC between services. A foundational component of Finagle is its service discovery system, which is based on something called the Zookeeper server set. So Aurora has a feature built right into it called the Announcer. Strongly recommend that you use this because if you use that in tandem with something called Linkerd, which is something that the Buoyant folks, I think they're just down the street, have done to wrap Finagle, it works right out the box with all of the server sets that Aurora will announce right out the box. So what you can do is that you can tell Aurora that you have the service and you have these particular ports that you'd like to expose on it. It will go and announce that to Zookeeper, and then you say to Linkerd on any of the machines that you're running, It's like, say, all right, I want to talk to that service, and I want it to listen on this port. And effectively, you talk to a port on localhost, and it goes through all of those many years of pain and suffering at Twitter, all that logic they built into Finagle to help you effectively make that RPC. So if you're looking to do service discovery, you really can't go wrong with the built-in Aurora announcer and Finagle and Linkerd. It is a winning combo, and it will save you a lot of pain, I promise. Oh, absolutely. That's actually another thing that I love about Finagle because, as an SRE, I feel the most interesting information is always in your high percentile metrics, particularly when it comes to latency because, whether you're in the middle of like a Java GC or whether you're dealing with another kind of esoteric problem like that, all of the useful information will be in the triple to quad nines for that. And so Finagle has an immensely massive set of metrics that it will expose right out of the box for every single client you set up. And those are exposed through Linkerd as well. Linkerd actually also includes this really swank kind of UI that you can have to look at that. It's honestly like some of the best set of metrics for exposing that kind of information in the business right now. Like we swore by it at Twitter. There were all sorts of extremely strange problems we would not have otherwise been able to detect without that extremely wide selection of metrics that, again, come out the box with that kind of a solution. Any other questions? Well, hey, it's been an absolute pleasure. Thank you so much for your time. Y'all have a great one.